Alright, so for this slide, slide A, you're expected to draw and label the specimen first. So I'm going to show you how to do that. And then you're going to be finding cell size, so you can do that next. So first of all, you want to always start by putting your specimen right over the top of the opening. And then you're going to go to the scanning lens, the shortest lens. Once you're on the scanning lens, you're going to use the coarse adjustment knob down here to get it into place so that it's pretty well focused. Then you can slide over to the low power lens, then use that small fine adjustment knob to get it even better focus, and then finally you're going to slide over to the high power and then use the fine adjustment again. So remember, never use the coarse adjustment knob when you're on low or high power. Then you're going to draw what you see in your notebook. Remember, what you need to do for this is trace out your index card, split it in half, and then everything you see you draw it nice and big on the left hand side and give it a label. This one is letter A, slide A. Okay, the second thing you need to do is find the cell size. So if in this picture you have multiple little cells, and we want to know how big one of those cells are, we need to know how big the whole field of view is, or the whole area you're looking at. So imagine you're looking through the microscope and you see this circle of light. The diameter of the circle of light, whether it's that way or that way, is called the field of view, or FOV. Now for the low power lens, which remember was that medium-sized objective, so for low power, the field of view, or the distance for the diameter of what you're seeing, is 450 micrometers, or UMs. Under high power, the size of that circle of light that you see, or the high field of view, is 1200 micrometers. So that's the first step in what you have to know to find the size of one of these cells. The next thing you have to do is you have to imagine that you've stacked those cells side by side, end to end, across your field of view. If you do that, you estimate to yourself, okay, how many cells would fit across? I'm going to count my estimation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and maybe a half. So about 10 and a half cells fit across my field of view. So to determine how big one of those cells is, what I'm going to do is I'm going to take my field of view. So let's say I'm under low power. My low field of view, remember, is 450 micrometers. So I'm going to take 450 micrometers and divide that by my 10.5 cells. And that is going to equal the size of one cell. If I was under high power counting those cells, I'd use that high power field of view, so 1200 micrometers divided by 10.5 cells, and that again would equal the size of one cell. The label on that measurement is also micrometers. So for that question, you need to figure out what is the cell size of these cells that you drew in the picture. And you put that also as a label on your drawing. So down here in the corner, in the bottom somewhere, you put your label for cell size. Make sure you show your work, just like I did, so that I know how you got that. Then remember, on the other side of the drawing, over here, you're going to answer two questions. Is this a human cell, and how do you know? And you're going to do that by going into your book or going online.